Hey everybody, what's going on? Welcome back to another new video. Today we're going to do a Arch Linux install guide. Wild Turkey 101, by the way. Can't go wrong there. If you are familiar with my channel, you might be slightly surprised by that, seeing as I have done actually a two-part Arch Linux install guide in the past. The thing is, that particular Arch install guide was a very weird scenario, and I think it was a decent video, probably, maybe, I don't know, but the whole premise of it was basically sort of an experiment. I was basically just moving from macOS with intermediate-ish understanding of how to use the command line and trying to install one of the most anarchic, I don't know if that's a word, Linux operating systems out there. The thing is, seeing as a huge part of my YouTube channel now is Linux videos, and the base for almost all of those videos is this incredible operating system known as Arch Linux, I thought we could do a little bit better and do an actual proper install guide now that I've done the installation process 5, 6, 7, 8, probably 10 or more times now, enough times that I know much more. So let's go ahead and do that here. This is the most up-to-date Arch ISO as of August 5th, 2021. I think I actually downloaded it yesterday, so we might be one day behind. But go ahead and boot the Arch Linux installation medium. I am doing this in a virtual machine, really doesn't matter. We're going to go through the same process here. The one thing that might hang you up is using Wi-Fi to install Arch, and frankly, probably the best practice for installing Arch is to just plug into Ethernet. Even if you are installing on a laptop, plug into Ethernet to do the install, and then you can install Wi-Fi utilities. But if you are looking to do Wi-Fi, I'm going to link to a pretty good video that I found the last time I was trying to do, I was trying to install Arch on a MacBook, and it literally didn't have an Ethernet port, so I had to use Wi-Fi, and I found a video to use one of the more up-to-date Wi-Fi utilities in Arch that explains it way better and in more detail than I probably could. So I'll link to that right in the description. If you're using Wi-Fi, check out that video, and then come back right here, and you'll be all set. But first thing you need to do, make sure you have internet access, so we're just going to ping a website. I got one of those. And we're all good. Everything's going well. If you need to adjust your keyboard layout, this would also be the time to do that. That's not an issue for me, so we'll move right on into the actual Arch install process. And the first thing we need to do is make sure that the system clock is accurate. So we're going to do time, date, control, set -ntp true. And then what we need to do is partition some disks. So there's two different tools that you can use to do this in the Arch installation medium. You can use fdisk, which is a little bit more of a sort of very minimal command line type program. I think it's fine. It's a fine way to do it. But what I always like to tell people is use cfdisk. It's just a much more guided process. One other thing I should mention is that we're operating under the assumption that you're booting into Arch using a sort of standard BIOS and not going through a UEFI BIOS, just because usually even if your motherboard does have a UEFI BIOS, which most of them do now, you're going to have an option to boot just using a normal BIOS, and in my experience, that's the best way to go. You can boot using UEFI. I actually do on my main production system, but since we have to choose one or the other, I'm going to go with a standard BIOS because I think that'll serve the most amount of people. So assuming that's what you've done, once you open up cfdisk, you're going to want to select DOS as the label type. And then what it'll do is it'll show you all of the disks in your machine. Now, you're usually only going to have one disk. Maybe people have more than one disk, but you can see right up here at the top of the app, it's going to list the disk that we're now editing is /dev/SDA. This is how everything works in Linux. You know, whether it's a hard drive or an actual literal file or something, it's going to be interpreted, and we're going to manipulate it basically just like it's a file in some location. So all of our disks, almost always, I think in basically every Linux distro, are going to be in /dev/SDABC through the alphabet. Some drives will have a different label. NVMe drives, most of the time that I've used them, have a label that's like NVMe 1, NVMe 2, that type of thing. But what you're looking for most likely is going to be labeled as SDA, SDB, SDC, that type of thing. So in this case, what we're going to want to go ahead and do is I'm going to create two different partitions. I'm going to create a swap partition and a normal Linux partition. If you don't know what a swap partition is, you can do a lot of research about that. Basically, I'm not super scientific about it, but the swap partition that you set is going to depend a lot on the amount of RAM that you have in your system. Basically, I just set it to 8 gigs always, something like 8 to 10 gigs is going to work pretty well for a swap partition. You know, if you have like only 4 gigs of RAM in your system, you're going to need extra space on a swap partition. So bump it up to 8. If you have 8 gigs of RAM in your system, just match it. If you have 16 gigs of RAM, well, you don't need as much space on a swap partition, so you can go down to 8 gigs. If you have over like 32 or 64 or something like that, you really don't need much of a swap partition at all. You probably should still make one of some size, but I think 8 to 10 gigs is probably a good size swap partition for just about everybody. So the size of our disk here is 60.6 gigs. So what I'm going to do is I'm going to hit new. And what I'll do, just so we can be super easy, is I'll do maybe a 52 gig first partition. And then we're going to set the type to primary, and this is going to be our main Linux partition. So if you look over here at the very top bottom, our ID is going to be 83 and the type is going to be Linux. If that is not the case for you, what you want to do is down here on the bottom row, navigate over to type with the arrow keys, hit enter, and go through this list until you find type 83 Linux. And then down here at the very end, you're going to have an option bootable. Click on that. You see an asterisk pop up under boot. And then we can go down to the rest of our free space, hit new. It'll default to using the rest of your drive. Hit enter, primary, and come over to type. And we want to choose type 82, which is going to be a Linux swap. And then once you have that, what we can go ahead and do is come down to the bottom, hit right, and then we're just going to type in yes. And we can go ahead and hit Q to get out of CF disk. Let me do lsblk-f. And what you can see is it'll list out the drive on our system. The drive is SDA, and we've now created 2 partitions, one called SDA1, one called SDA2. SDA1 is our main drive, SDA2 is our swap partition. So what we want to do is we're going to do make file system in order to format the first partition so that we can actually store files on it. And if you just type in mkfs period and hit tab, you'll see all of the different options that Arch gives you by default for file systems in terms of drives. ext4 is, I think, what Arch sort of officially recommends you use on the Arch wiki. More recently, I've taken to using BTRFS or ButterFS, which should be slightly more secure. Is mainly the gist of what I got. I did a little bit of research about it, and I was going to try it out either way just to see how my system performed with a different file system, and so far it's been fine. So I'm going to stick around with ButterFS. So then what we need to do is just type in the location to our drive. If you remember from CF disk, all of our drives are going to be in /dev/something. We're going to go ahead and type in SDA because we know it's going to be SDA, and you see using tab complete, we can complete to SDA1 or SDA2. This is our first partition, our main Linux drive, so I'm going to do SDA1, hit enter, and everything will work. We don't have any errors. Then we just need to sort of format the swap drive. The way we can do that is we're just going to do make swap, and we're going to make it on /dev/SDA2, the second part of our partition now. Now we have to mount them. What you're going to do is mount, and we want to mount /dev/SDA1, our first partition, to /MNT, and then we can go ahead and do swap on /dev/SDA2. And from this point, we're actually good to go ahead and install Arch Linux using the packstrap command. But before we do that, what a lot of people like to do is use a program called Reflector to download a mirror list so that we can download things a little bit faster. And I think that's probably a good way to go. So we're going to do pacman-s, and we want to install Reflector. And then we actually need another package called rsync in order for that to work correctly. Oh yeah, that's right. Before we do that, we need to do pacman-syyyy to sync all of the repositories that we have access to. So we do that, then we run pacman-s, reflector, and rsync. Go ahead and install both of those packages. And so now we can download a mirror list. There's a few different ways that you can use Reflector. I think probably the easiest way to do this is we're gonna run Reflector, and we're gonna do -- country or -c and give it a country code. In my case, I'm in the US. And then I'm gonna do -- latest, and I wanna say maybe give me the latest 20, and then I wanna do sort, and I wanna sort by rate, which should sort the fastest at the beginning, and then -- save, and we wanna save it to /etc/pacmand/mirror list. Go ahead and run that, and this actually will take a bit because basically what it's going to do is ping a whole bunch of different mirrors to try to find the fastest and then organize a mirror list for us. Okay, so it looks like it's done now. If we wanted to, we could open up maybe, I think we probably have V on here, or we have Vim. So what we could do is we could run Vim, we could go into etc pacmand mirror list, and you'll sort of see what's happening here. It's basically built a mirror list. You can see there's 20 mirrors in here. Ideally, these are going to be sorted the fastest on top. These are all US mirrors, and it'll actually show you exactly what command you ran up here in order to generate this file, and it'll show you when you've done it. And in a bit, we'll mess with the config for reflector so that this process will happen sort of automatically over time towards the end of the install, so that we never really have to jack with our mirror list again. Go ahead and quit out of this if you don't know how to exit Vim. Probably the easiest way to do it is type :Q. All right, so now we're gonna go ahead and install software, which is the most fun. Officially, the way that you're told to do it on the Arch Linux installation guide is to run pacstrap on /mnt, which remember is where we mounted our main Linux drive. And you want to install 3 packages: base, Linux, Linux firmware. And this is good. You need all of these packages. There's a few different ways you can do it. There's a few different Linux kernels. You can install the LTS kernel, which is what Ubuntu uses. You can install the hardened or the Zen kernel, which are sort of supposed to be more security focused. Just keep in mind, if you do use a different Linux kernel like the LTS kernel or the Zen kernel, some of the other programs that you install, you might have to be a little more careful about what you're installing. For example, NVIDIA drivers. It matters very much which NVIDIA package you install based on which Linux kernel you install. So if this is your first time around, just use the standard Arch Linux kernel. There's nothing wrong with it. It'll work perfectly fine, and it'll make getting support a whole lot easier. So we're going to install base Linux firmware, and then the other thing that we're going to need just immediately is we're going to need a text editor. So you can install Nano or Vim or NeoVim, whatever you're into. I'm a NeoVim guy, so I'm going to go ahead and install that, and that's probably good for now. We will go ahead and install Reflector, just because I want to make the point that when we installed them earlier, we were just installing them onto the actual installation medium. Only now, when we're running pacstrap on /mount, are we actually installing apps that are going to be on our final system when we boot. Which is why we had a text editor a minute ago when we opened up Vim to look at the mirror list. When we move over to our new mounted drive, as soon as we're done installing here, we're not going to have a text editor. Go ahead and hit enter, and I guess now would be a good time to mention that timer that you're seeing up in the corner of the video. Basically, I just thought maybe to add tension, it would be a good idea to add a timer, and then I started recording the installation, and I forgot that I decided I was going to do that, so I didn't remember to mention it until now. And we're basically just trying to see how quickly can I install Arch to get to a usable system. The download times are not going to be included in this, which is why the timer isn't going to be moving right now, but I don't know, I thought that would be interesting. Okay, we're done. So now we have installed Arch Linux onto our actual hard drive. And what we need to do is move over to that hard drive to start manipulating things. Right now, we're still in the actual Arch installation medium. We need to run gen fstab-u on /mnt and put that data into /mnt/etc/fstab. Once we've done that, we're actually good to go ahead and move off of the ISO onto our drive. So we're going to do arch-chroot onto /mnt. Our prompt will change, and we're onto the actual drive that we just installed Linux on. So first thing we need to do here is set a time zone. We're going to do ln-sf/usr/share/zoneinfo. And then if we go ahead and hit tab here, it'll list out all of the different countries that it has time zone support for. I'm going to pick the US here, probably a good idea. Hit /, hit tab, and it'll list out all of the US time zones. I am in the central time zone, and we're going to put that into /etc/locale time. What we just did is we created a link from a file in /user/share/zoneinfo/US central. And what this is doing is taking the central time zone info and then linking it to a new file we just created called local time, which is where Arch is going to look to figure out what our time zone is. From here, now that we have a time zone info, we can sync up our system time. So we're going to do HW clock /systochc system to hardware clock. We're syncing system clock and hardware clock. That one explains itself. And then what we need to do is generate locals. 2 parts of that. First of all, we're going to use a text editor. We've got in Vim here, and we're going to go into etc/locale.gen. And in Vim, what you can do is you can hit / and I'm going to search for en_us. And then you can navigate using lowercase n. And what you want to do is find the line that's going to say en_us UTF-8. Go to the hash right in front of that, hit X to remove the hash. And then what you can do is you can just hit capitals Shift Z twice, and that'll save and exit Vim. And from there, what we want to do is run a command locale-gen. That one's going to give us output and tell us when it's done. Cool. And then what we need to do is we need to use invim one more time to go into etc/locale.conf and put in that info again. We're going to do language equals en_us. In my case, again, use whatever your country code is, and then just add .utf-8. Go ahead and capital Shift Z twice again to save and exit. And if you listen closely, you can now hear my neighbors stomping upstairs, which they like to do all night long. So we're getting pretty close to the end here. Let's make a host name really quickly. We're going to do invim/etc/host name. And we just need to type in the name for our system here. So I'm going to do pickled red onions. Save and exit. And then what we need to do is use invim again to go into /etc/hosts. Make a new line. We're going to type in 127.0.0.1, hit tab, come over here. We're going to type in the local host. We're going to do ::1, 2 tabs, local host, 127.0.1.1, tab again. And we're going to type in our host name, pickled red onions, dot local domain space, and then our host name one more time. So now we're getting really close to the end here. We're going to set a root password. We're going to install a couple more apps, and then we can set up grub so that we can actually reboot. So we're going to do password, PASSWD, type of password, make sure it's very secure and difficult to duplicate. And then we can go ahead and install some more apps here. So we're going to do pacman-s, and the first thing we need to install is something called grub. This is a bootloader. It's what's going to allow us to actually boot in our system. The next thing we need to install is DHCP-CD, which is what's going to allow us to turn on the networking, Ethernet, when we reboot. We need Git. We're going to do OpenSSH. We're going to install the base developer package as well as the Linux headers package. These are going to make sure that we can install the AUR later, and they're just generally helpful for building apps, which is something you will occasionally have to do. Maybe not necessarily, but more than likely might end up needing to build an app from source once or twice on Linux. And then something that a lot of people forget to mention is AMD Ucode or Intel Ucode. This is microcode that is gonna, depending on your CPU, add support to Arch. Probably I think the reason people forget is you can skip this step a lot of the times and never really have a problem, but every once in a while things might start breaking, and there's a decent chance it's because you did not install the microcode for your CPU. So depending on what CPU you're using, AMD Ucode or Intel Ucode, I'm running Ryzen here, so AMD Ucode. If you are unaware of that, whether you're using an AMD or an Intel CPU, I don't want to say that maybe you shouldn't be installing Arch, because that seems a little douchey. You know, certainly you could be really into software and not give a shit about hardware, but come on, you can figure out what kind of CPU you're running. I think that can be sort of the floor here. Yeah, that's probably enough. We'll go and install all that. Actually, maybe we'll go and also just install Xorg, because we're going to need that. So we'll hit enter. Gonna hit all again, hit yes, and this one's going to take a minute because we are installing quite a bit of stuff here. How many packages? Oh, 144. This is done. Okay, cool. Now we're going to make sure that we're good to reboot here. In order to do that, we want to do three things: enable the reflector service, enable the DHCP-CD service, and set up grub. So first thing we can do is we're going to run grub-install, and we're going to do --target equals i386-pc on /dev/sda. Make sure you're not doing SDA1 or SDA2 here. We're not trying to install grub on a partition. We're trying to install it for the entire drive. Go ahead and hit enter. And this is going to give us an output here too, so we'll know whether we failed or not really quickly. Installation finished, no errors reported. As you may have assumed, that is a very good sign. And then we just need to actually make a config for grub. So we're going to do grub-make config-o onto /boot/grub/grub.cfg. Now we can move on to let's go ahead and enable DHCP-CD first. So we're going to do system control enable DHCP-CD.service. So if you forget to do this, it's not the end of the world. Just what you would have to do is every time you log into Arch before you can connect to the internet, you would have to do systemctl start DHCP-CD.service. So if you do forget to enable this, Don't think you need to reinstall or anything, just run this command, and once you have DHCP-cd started, you can then run system control enable DHCP-cd.service, and you'll never have that problem again. Let's go ahead and do the same thing with Reflector, so that it's going to be catching new mirror lists all the time. Systemctl enable Reflector. I think actually it really just reflects updates in the mirror list whenever you restart, I believe is how it works. Don't hold me to that though. We're going to enable that service. And then really quickly before we reboot, the last thing we need to do is we're going to go use a text editor, go into etsy/xdg/reflector/reflector.conf. And what are we doing here? So we want to just make sure that we're editing and making sure that everything is good to go here. So under --save, we want to make sure we're saving an etsy/pacmand/mirrorlist. Under protocol, HTTPS, that'll work fine. We can sort the mirrors by age, I suppose is actually the better way to do it, is what it recommends. I usually sort by rate when I'm running the command, but I guess they want you to do it by age, that's fine. It's saying it only wants to use the 5 latest synchronized mirrors, so I guess, no, give me 20. I don't know, 20 seems like a better number. And then here under the country, I'm going to go ahead and change that to US. You can list multiple countries if you're in Europe or something, and you know, different countries are as close as different states here are from me. Exit and save, and we're good to go ahead and reboot here. Sudo power off or reboot or whatever. So now we are at a part where it's going to want the login. If you did not create a user account, which we did not, we're going to log in as root and then give it the good old root password. Now we're in. So I guess the first thing we should do is actually just create a user account. This is usually a good way to go. It's a really good way to go. It's a great idea, actually. Almost recommended. It's definitely recommended. Before I do that, though, I am going to do pacman, or let's cat out etsy/shells, which will tell us all the different shells that we have. We don't have Zeesh, which I thought Arch came with Zeesh for some reason. So I will do pacman-s and install Zeesh. Cat out etsy/shells again. You can see user/bin/Zeesh is installed now. So what we can do now is user add -m, which is going to create a home group. -g would add any additional groups, which we do want to do. And we want to add this user to the wheel group. I'll show you why in just a second. And then we want to use -s to select a login shell. And we're going to select /user/bin/Zeesh, which we just installed. And then we would just want to give this user a username, which is going to be Mac. And then we can go ahead and do password Mac. Give our user a password. Again, make sure it's very secure. It's a great idea. And probably good there. We just need to do editor equals invim, and then we want to do v sudo. Hit capital G to come down to the bottom of the file. And what we're looking for here are one of 2 different lines. The first one is going to be wheel all equals all, and the second one is going to be wheel all equals all, no password. What this is going to do is allow users of that wheel group, which we just added this new user to execute super user commands. And then you can also do it without a password. So what that means, that doesn't mean that you don't have to put in a user password or anything. It just means that like when you run like sudo pacman-s to try to install an app, you don't have to then type in a root password to install apps. You just are granted those privileges without having to provide the root user password again, because our OS is basically treating you not like you are the root user, but like you're friends with them. You're really good friends with them. They trust you. I do typically do wheel without a password just because, I mean, this is a home system. If I was trying to be like super secure or something, if it was a laptop, maybe not the best idea, but yeah, it's fine. Go ahead and exit here, and let's just go ahead and do sudo pacman-syu. Or no, you know what? Actually, what we should do is we should move to our new user now. So we'll go ahead and exit, and then we'll log in as Mac, give it the password, and then what we can do is we're going to do sudo pacman-syu just to make sure that all of the software that we have is up to date, and then we'll go crazy doing some other cool stuff. Okay, so there's nothing to do. Cool, that means everything's up to date, and we can go crazy here. So what I want to go and do is make a directory called repo, where I want to store my dot files. If I list now, I have that directory. I can cd into that directory, and then what I'm going to go and do is I'm going to do git clone from https://github.com/mac/ dot, which are my dot files, which is what I use to customize a lot of the command line apps. And then I'm going to do latest one, I think is how you do it. Oh, sorry, no, that's not what I meant to do. I meant to do depth one, which should pull down just the most recent commits so that I'm not downloading the entire Git history, which again, if I was downloading this on a main production machine, I would want the entire history, but I don't here. I just want to download sort of the quickest version. And then what do we do? We'll go back into our home directory, do ls-la to list all of our files here. Now what we can do is link from that repo dot folder that I just created. So what I'll do is I'll do ln-sf and I'll link from repo .config and drop that into our home directory. And then I'll do the same thing with repo.scripts, drop it here. And you can see sort of what that's doing. If I list again, it's creating links so that we can access those files, but they're still Git controlled. So we'll do ln-sf from repo.git config maybe, link that here. And we'll do link up my Zeesh settings. That's always fun. And then if I actually do source.config/zeesh.zeeshrc, should be able to reload Zeesh now. And cool, we've got some prompts here. And then what do we need to do here? We need to go ahead and let's do set up the AUR. So we're going to do git clone https://AUR dot archlinux.org/yay.git. Let that do its thing. Then we'll cd into the yay folder. And then once we're inside of that yay folder, what we can do is make package-si, hit enter, and this is going to go ahead and build yay for us. And go ahead and give us the option to install it. And then finally, we can do our last pool of apps to get everything installed. So what we're going to do is sudo pacman -s, and we're going to install Awesome. We're going to need a browser. I'm going to do Firefox. We're going to need a terminal. I'm going to do Alacrity. Maybe I'll grab dmenu as well. And it's going to ask us to pick some fonts. Then we just let that install. It's going to be, again, it's another one of these sort of big package pulls, but it shouldn't take too terribly long to install. One more thing I forgot to do, yay-s polybar. That's basically a guaranteed necessity for one of my setups. You know what I can compare Arch Linux to? Check this out. This is like my favorite thing I've ever bought. This is a Alden 405. This is the shoe that Indiana Jones wore, at least the original trilogy. It's a great shoe. And I mean, in theory, maybe it won't last your lifetime, but as long as you properly take care of that, it sort of ends the cycle of like, well, it's another year, so let me buy another shoe because I just walked through the other one I had. You know, you'll take it and get it resoled or put a new insole in it, or maybe get some rivets repaired or something in it every once in a while. I rip through laces all the time, tie it up real fast and destroy laces, but it's a great shoe, and Arch Linux is a great OS. Speaking of which, we are now ready to boot into what I would consider to be a usable version of Arch. So, 2 steps, listen closely here. Step 1, in Vim, create a new file called xinitrc. In this file, type in exec awesome, save and quit. Step 1.5, if running startx doesn't work for you, do yourself a favor and run sudo pacman-s, xorg, xinit, and xorg server. Every once in a while I run into that problem. Doing this fixes it. But now we can go ahead and run start x, and then let's go and do sudo pacman-s and install fay so that I can set a wallpaper. And in the meantime, maybe we can open up Firefox here, and we can set GTK themes and stuff. For now, maybe we'll just download some wallpapers. If you're looking for something like that, I can help you out here. I've got a collection of sort of neon style funky ass wallpapers you can download. I'll rep my own brand here just because I can. There we go, got a nice wallpaper now. And hey, you know what? This looks pretty good. There's a few things that aren't going to work just because I'm in the VM, like transparency and stuff. PyCom doesn't work in the VM because I just don't have the settings set up right and I'm too lazy to fix it. But I mean, honestly, for the most part, this isn't a bad way to work here. I mean, I've got just about everything I need here. I mean, let's be straight. For most people, all you really need is a browser, and we got that right there. But, you know, if there's any other apps you can need, I'll just sort of collect them as I need them. I don't have like a mass list of stuff that I install on every new system or anything crazy like that. This seems like enough of an install, and I'm happy saying like, okay, I can get to work now. I don't have to worry about getting stuff installed anymore. So I guess we'll call it quits. Thanks for watching, everybody. See you in the next one.